Find the second derivative, g double prime of x, for the function g of x equals 2 square root of x plus 1 over the square root of x. Then evaluate g double prime of 9. So g of x here is made up of two terms that are combined together by addition. We can therefore take the derivative of each term separately and combine the results by addition. But before we do that, let's rewrite each of these square root of x terms as x to the first power second root. And for the second term, we will have 1 over that x to the first power second root x to the 1/2. Because the numerator of the second term is a constant, there's no need for a quotient rule. Instead, we can rewrite that second term. Keep the first term the same. For the second term, we can move the x to the numerator with the 1 as a negative exponent. Each term will now just follow a power rule. To find the second derivative, we will need to first find the first derivative. The first term will bring the power down 1/2, leave the inside alone, subtract 1 from the power, I will call that 2/2, and multiply by the derivative of the inside to complete the chain rule. Derivative of x is just a 1. Plus the second term, we will bring down the power, minus 1/2, leave the inside alone, x, subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside, which is a 1. Then this first term, we can multiply all of the constants. A 2 times a 1/2 times a 1 is 2/2, or just 1. And we have x to the 1 minus 2 negative 1/2. The second term, we have a negative 1/2 and a 1 multiplying each other. That'll be a negative 1/2. And x raised to the minus 1 minus 2 minus 3/2. We're going to want to keep it in that form to be able to take the next derivative, the second derivative, g double prime of x. Will just be power rules off of each of those terms. First term, bring down the power, negative 1/2, x raised to the, subtract 1 from the exponent, multiply by the derivative of the inside to complete the chain rule. Second term, we will bring down the power, a negative 3/2. Leave the inside alone, subtract 1 from the power, I will call that 2/2. Multiply by the derivative of the inside to complete the chain rule. So our second derivative will have its first term. We have a negative 1/2 and we have a 1, negative 1/2. We multiply those, and then x raised to the negative 1 minus 2, negative 3/2. And then the second term, multiplying the constants, a negative 1/2 times a negative 3/2, multiply the numerators, negative 1 times negative 3 is positive 3, multiply the denominators, 2 times 2 is 4, positive 3/4, and then we have it multiplied by the 1 over here, which will keep it as a positive 3/4. X to the minus 3 minus 2 minus 5/2. Before we evaluate this, we are going to want to rewrite those negative exponents in the denominator as positive exponents. This first one will move down with the 2. The second one will move down with the 4, already in the denominator of each of those. So our first term, we will have a negative 1 over and 2x to the positive 3/2. And our second term, we will have a 3 over 4x to a positive 5/2. Now we can evaluate g double prime of 9. And g double prime of 9 is going to be negative 1 over, we're going to plug a 9 in for each x, so 2 times 9 to the 3/2 plus a 3 over a 4 times a 9 to the 5/2. So we have a negative 1 over 2 times 9 to the 3 halves. 3 halves means the square root of 9, which is a 3, and then cube the result. And then plus 3 over 4 times 9 to the 5 halves. 5 halves means square root of 9, 3, and then raised to the 5th power. Now we are able to cancel one of the 3's out for the second term, so that'll be left with a 1 in the numerator, and this will now be to the 4th power in the denominator. So we have negative 1 over 2 times 3 cubed plus 1 over 4 times 3 to the 4th. Now we are going to want to combine these together with a common denominator. It may be best to leave it in this form here to see what the common denominator is. This first term has 3 3's, the second term has 4 3's. We need one more 3. And this first term has a 2, and the second term has a 4. We're going to need one more 2 while we're at it as well. So that first term is going to need another 2 and another 3 to complete the common denominator. So I'm going to multiply the numerator by a 2 and a 3 and the denominator by a 2 and a 3. Notice I'm not expanding the 2 times 3 cubed to the 4 times 3 to the 4th. It's easier to see the common denominator for big numbers when it's in its factored or prime factorization form that we have here. Now for this first term, the numerator will be the multiplication of these, 1 times 2 times 3, and then the negative. Well, 2 times 3 is a 6. And the denominator, I will just combine the 2's, multiply the 2's together, a 4, and then I have a 3 cubed and another 3, and I can just write that as 3 to the 4th. For now, we will expand that. And the second term, I'll just keep it the way it is. And now you can see that we have a common denominator. These can combine together, and it will be equal to negative 6 plus 1, negative 5, over 4 times 3 to the 4th. 3 to the 4th, 3 times 3 is 9. And we can break 3 to the 4th into 3 squared and 3 squared, as long as they add up to 4 for the exponents. 2 plus 2 is 4. And since 3 squared is 9, I can replace each of those with a 9. So 4 times a 9 times a 9. And so I'm going to have negative 5 over 4 times 81, which comes out to negative 5 divided by 324.